gentlemen, I have the total honor to stand up on Laas podium to share with you the tough work did on the 5 months ago. The main objective of this work is to implement the first amateur radio club in Lebanese university that will have a main purpose to communicate with astronauts in space station and satellites. Amateur radio begins in 1920. Through its origin can be traced to at least the date 18. The birth of amateur radio was strongly associated with various amateur experimenters and hobbyists. Amateur radio enthusiasts have made significant contribution to science, engineering, industry, and social services. In Lebanon, amateur radio founded in 1952 and well organized. How satellites work? We have GEO, MEO, and LEO, three main orbits around the Earth. GEO satellites rotate in the same speed of the Earth as shown in this picture. Different than LEO, the LEO rotate different speed than the Earth. It's much speed than the Earth. So we can clearly notice that GEO will cover the same area 24 hours per day like NightSat and Arabsat, while LEO satellites cover the same area 10 to 15 minutes only, and MEO cover the same area only 2 hours to 8 hours. So how it's work? Let's take an example. If we have A in this place, we'll communicate with B in the other place. A will send an uplink channel to the satellite. The satellite will repeat this channel as a downlink to B and vice versa. It can send voice, data, or video, or anything we want. ISS is the only satellite where we can find people to communicate with, and these are frequencies allocated for this satellite. As a downlink, they use 145.8 megahertz. And regarding the Middle East, it's classified as region 1, so we use the 145.2 megahertz as an uplink. In order to succeed in tracking the movement of satellites, I had to create a circuit to control the tripods that handle the antennas. Here we have a microcontroller, PIC16F877. It links the input's potentiometers with the output motors. These potentiometers is divided into two categories. The first two potentiometers is dedicated for the control part, and the other is fixed on the tripod in order to get feedback. This display shows us the info needed for the current antenna orient direction. This block diagram describes the algorithm of the code. After initializing the system and the PIC, it will display some info on the LCD. Here the PIC will test if the potentiometer on the control board vary larger than the azimuth on the tripod, then the motor will turn right, else it will turn left. Same idea for the elevation. If the potentiometer on the board control change greater than the elevation on the tripod, the motor will rotate up, else it will rotate down. And also, here we can see the final design of my circuit, and here we have a zoomed-in picture to the feedback potentiometer, which is connected to the axis of elevation, and here we have the feedback azimuth, which is connected to the azimuth axis, and here we have the final design of my work. As software, we use the software called Nova for Windows. This software is live real-time tracking satellite. No need for the internet to track the satellite. Only we have database that can draw the movement of the satellite on the world. We should locate our observer and find the location of the satellite. To predict the path and its status, we have many websites. I use this website to predict the path. This website gave us a status about this path, an excellent path, good, marginal, or it's not visible. After do communication with satellite, if any problem occurred, we can check the status of the satellite itself. Maybe the satellite will be no signal due to low battery or something, or maybe it's active, so we can predict or know that our system has some problem. About the communication system, I use the Yaozu FT 7800, which is the dual band transceiver that covers the 2 meter and 70 centimeter band. And here we have a log periodic antenna that covers the 144 megahertz band, and the other log periodic antenna for the 440 megahertz band. And for the best connection, I used the RG213, which is low loss coaxial cable in the market. About the radio club, the mission is to promote amateur radio in the community and provide training and support required to become an amateur radio operator. Maintain radio system suitable for providing communication for the benefits of the community and assist civil authority when requested. This is the main case of OD5 MUT. It gave the members or visitors all news, registration form, etiquettes, and rules. And the main idea or benefits from this site, we have the live audio streaming. This live audio streaming gives the users the opportunity to follow us online if we can't attend this session. As a conclusion, I successfully accomplished the work, and the amateur radio club at MUT is capable to communicate with any satellite. I sent an email to the ISS. They replied that I should fill up a form in order to communicate with them. And I believe that engineers live to improve and enhance. So we can enhance the mechanical part and electrical part of the entire system. Also, we can create a software that controls automatically the tripod without change the potential meter. And I hope to communicate with the ISS as much as possible to achieve rewards and perfection. As acknowledgement, I would thank Dr. Amani Raad and Dr. Walid Kamali and Mr. Hani Raad and my family who helped me in this project step by step. And thank you.